Alright, this is lesson 6.6, the general form of the equation for a linear function. This is our final section of our linear function unit. In the last two sections, what we've looked at is in 6.4 we learned about the slope-intercept equation of a line, commonly known to as y equals mx plus b. There were benefits of using that one. Next lesson in 6.5 what we looked at the slope point form. There were benefits of this one. Same with general form, and this is the general form equation that we have right here, that guy like so. There's benefits of this equation. The main benefit is that you can find the x-intercept and y-intercept really easily. And once you've done that, that gives you 2 points on a graph, and whenever you have 2 points on a graph, you can graph it, as we know, quite easily. So let's give these a try. What these examples are going to look at, they're really relatively simple. You're just going to take one equation, so for instance like this first one's in y equals mx plus b, and we're going to try to transfer it over to general form. Okay? In order to do that, in order to put something into general form, though, there's these three conditions that we must obey. Okay? So the first one is that they must be in the correct order. What I mean by that is this order that I have up here, ax plus by plus c equals 0, must go that way. The x term's first, then the y term, then your constant is equal to 0. Okay? Second thing that we need to do, we need to have the leading coefficient must be positive. So that means up here, this a right here, I want to make sure that the a is positive, and there's ways that we can manipulate our equation to make sure that that always happens. Last thing we have to have is we don't like to have fractions, so we're going to get rid of the fractions. Okay? Now it's really up to you when you get an equation like we have here in example 1 as to which one of these three conditions you want to deal with. Right here I see I have fractions, it's definitely not in the right order, and I see that the leading coefficient of the x is negative, so that's a problem. It's up to you what you want to get rid of first. What I'm going to choose to do here is I normally like to get rid of my fraction, so I'm going to multiply everything by 4, and you'll see when I multiply everything by 4 the fraction is going to go away. I get 4y is equal to negative 1/4 times 4 just gives you negative x, or negative 1x, plus 12. So I've accomplished the no fractions. What I'm now going to try to do is deal with this order. Alright? Well, I can kind of do two things at once here. Since I notice that the leading coefficient of my x here is negative, it makes sense that I might want to move the x to the left-hand side of the equation. Students often ask, well, how do I know what side to move it to? Move to the side of the equation that's going to make it positive. So if I move everything to the left-hand side here, I'll end up getting x plus 4y minus 12, moving the 12 over as well, is equal to 0. And you see I've met 1, 2, 3 of the conditions. And so that would be that equation written in general form. Okay, let's try number 2, or B here. You might want to try this one on your own. We're going to try to accomplish our order, make sure the leading coefficient is positive and no fractions. Okay, it's up to you how you want to do that. What am I going to do here to start this one? I'm going to multiply everything by 2 myself to go and get rid of the fraction that we have right here. Okay. But before I do that, I'm going to go and multiply this 3 over 2 into the x and to the negative 4 using the distributive property. Doing this, I get 3x over 2 minus 12 over 2. Okay? And of course, 12 over 2 is just equal to 6. So if you want, you could just write this as minus 6. So right here, we do have that pesky fraction we want to get rid of. So at this stage, I'm going to multiply everything by 2, and I get 2y plus 4 is equal to, those 2's will cancel, giving you the 3x minus 12. Okay. At this stage, this one's kind of unique because for the equation that I dealt with in A, remember how I moved everything to the left-hand side of the equation over here? This time I'm probably going to want to move everything to the right-hand side. Why I say that is, notice that the x is already positive over there, so you might as well move everything over there to meet it. So I'm going to have 0 is equal to 3x minus 2y minus 16. Moving the negative 4 over, combining it with the negative 12, gives you that equation written in general form. Okay. Now let's go on to the next page, and this is where we can finally see what the benefit of the general form really is, in my opinion. The benefit that I see here is that we can determine the x-intercept and y-intercept relatively easily. So if you take the equation 3x plus 2y minus 18 equals 0, and you want to find the x-intercept, what you're always going to do is you're going to set the opposite variable, so I'm going to set y equal to 0. So when I do this here, I have 3x plus 2, and I'm going to substitute in a 0, minus 18 equals 0. And then I'm just going to solve for x. When I do this, I have 3x, I'll move the 18 there aside, equals 18. Dividing by 3, I end up getting x is equal to 6, like so. Well, what's that ordered pair? That would be the ordered pair 6, 0. So you can go and plot that point on here. We have 1, 2, 3, 4, 5, 6, like so. Now to determine the y-intercept, you really just do the same thing, of course, only we're going to set x equal to 0. So always the opposite. So this time I'm going to have 3 times 0 plus 2y minus 18 equals 0. This gives me 2y, moving the 18 to the other side. Y is equal to 9. And so this time we have the ordered pair as 0, 9. And so climbing the y-axis here at 1, 2, 3, 4, 5, 6, 7, 8, 9. Draw your dot and get out your ruler. And we have the graph of this equation. Okay. Lastly, example 3, another relatively short lesson. Determine the slope of a line with this equation. So what they want you to do is they want you to easily find the slope. Well, if you think of it, there's two equations that you could try and put this into. You could put it into the slope point form of a graph, or you could put it in the slope intercept form. I'm kind of a fan of putting it into y equals mx plus b. I think students usually find it a little bit easier, so that's what we're going to try to do here. So my little tip for you, and you can try this, is to put equation into y equals mx plus b. And of course your m will represent the solution for this problem that they gave you. So let's start out with our equation. 5x minus 2y plus 12 is equal to 0. And remember, we're trying to put it into this format. So basically what we want to do is isolate the y. Well, I can see if I just move the y to the right hand side of the equation, I have 5x plus 12 is equal to 2y. I'm almost there. Lastly, if I just divide by 2, I have y is equal to 5x over 2 plus 6. So 6 being my y-intercept, they didn't really ask for that, but of course they did ask for my slope. My slope is right here, the 5 over 2, and I can say to answer the question that slope is equal to 5 over 2 for this example. Okay. So to conclude this lesson, a little summary here. What have we learned? We've learned that a different format, the general form of the equation of the line, must meet the three conditions. Everything must be in the correct order. The leading coefficient must be positive, and there can't be any fractions. What is this useful for? It's kind of useful for graphing when you want to figure out your x-intercept and your y-intercept easier than using another method. Okay, that concludes this lesson.